Good evening, everyone. I'm just gonna have to do a little sound check because tonight we're doing something a little bit different. Good evening, everyone. I'm just gonna have to do a little sound check because tonight we're doing something a little bit different. Apologies for the song you're about to hear. It's just a test for me to see if the desktop audio is coming through all right.
We're no strangers to love. You know the rules, and so do I still commit. It's what I'm thinking of. You wouldn't get this from any other guy. I just wanna tell you how I'm feeling.
Getting some backup help in backup help. Getting the wifey to test the setup. Oh. Be quick to try. I just wanted to check that. So tonight we're going to be jumping into the first foray of learning Go, not Golang, but Go. I'm going to do this all on stream. Tonight we'll cut off about at 10 o'clock, so we might be able to get through most of a few videos that we've got. Just want to make sure that the setup is right first. So I don't want the sound to be echoing through the microphone whilst I'm listening to it as well. So tonight, this is the start of me learning Go. So let's go. Check that the setup's all right for everything now. Get through ads.
And we're back. The team is looking down the barrel of a 4:55 meeting.
Go, a statically typed compiled language often described as C for the 21st century. It's a popular choice for high-performance server-side applications, and is the language that built tools like Docker, CockroachDB, and dgraph. It was created at Google in 2007 by legends who really know their stuff, like Ken Thompson, the inventor of the B and C programming languages. Version 1.0 was released as open-source software in 2012. It was designed for simplicity and efficiency, and that's why we call it Go and not Golang. The source code is compiled down to machine code, which means it generally outperforms interpreted languages, but it's famous for its extremely fast compile times, made possible by innovations to dependency analysis. And even though it's a statically typed language, it performs type inference to deliver a syntax that is very concise and practical. It also has a package and module system, making it easy to import and export code between projects. To get started, install Go and then open an empty directory on your system. Create a file ending in .go, then add package main at the top to create a standalone executable. Then declare a main function, which is where your program will start executing. Go has a standard library of core packages to handle common requirements like math, networking, or formatted I/O. By importing FMT, we can print a line to the standard output, then run the go build command, and it quickly compiles the source code and dependencies into an executable binary. When it comes to dependencies, we can also link to remote packages on GitHub, run go mod init from the command line, and that creates a Go module file that enables dependency tracking. Syntactically, Go is like a concise version of C or C++. Declare a variable with the var keyword, followed by its name and type, and initialize it with a value. Or you might use the short assignment syntax to replace var, and let Go automatically infer the type. And you can define multiple variables from a single line. Go has all the other features you would expect in a programming language, like arrays, maps, loops, and control flow, but also allows you to store the memory address of a value using pointers, while disallowing pointer arithmetic, which often leads to dangerous and unpredictable behavior. In addition, it supports concurrency with Go routines, which are functions that can run at the same time as other functions by utilizing multiple threads on a CPU. This has been Go in 100 seconds. Hit the like button if you want to see more short videos like this.
If I speak out on my voice, just see that for comparison. Try one more time.
Go, a statically typed compiled language often described as C for the 21st century. It's a popular choice for high-performance server-side applications, and is the language that built tools like Docker, CockroachDB, and dgraph. It was created at Google in 2007 by legends who really know their stuff, like Ken Thompson, the inventor of the B and C programming languages. Version 1.0 was released as open-source software in 2012. It was designed for simplicity and efficiency, and that's why we call it Go and not Golang. The source code is compiled down to machine code, which means it generally outperforms interpreted languages, but it's famous for its extremely fast compile times, made possible by innovations to dependency analysis. And even though it's a statically typed language, it performs type inference to deliver a syntax that is very concise and practical. It also has a package and module system, making it easy to import and export code between projects. To get started, install Go and then open an empty directory on your system. Create a file ending in .go, then add package main at the top to create a standalone executable. Then declare a main function, which is where your program will start executing. Go has a standard library of core packages to handle common requirements like math, networking, or formatted I/O. By importing FMT, we can print a line to the standard output, then run the go build command, and it quickly compiles the source code and dependencies into an executable binary. When it comes to dependencies, we can also link to remote packages on GitHub. Run go mod init from the command line, and that creates a Go module file that enables dependency tracking. Syntactically, Go is like a concise version of C or C++. Declare a variable with the var keyword, followed by its name and type, and initialize it with a value. Or you might use the short assignment syntax to replace var, and let Go automatically infer the type. And you can define multiple variables from a single line. Go has all the other features you would expect in a programming language, like arrays, maps, loops, and control flow, but also allows you to
There we go. I think we're all sorted now. Thanks, wifey. Goodbye. Okay, right. Let's start this properly again. So, learning Golang. This is the start of the journey. We've got everything set up. There's no more problems now. We're going to have a timer. It's going to be 1 hour and 40 minutes. We get where we get to. So, let's roll.
Go, a statically typed compiled language often described as C for the 21st century. It's a popular choice for high-performance server-side applications, and is the language that built tools like Docker, CockroachDB, and dgraph. It was created at Google in 2007 by legends who really know their stuff, like Ken Thompson, the inventor of the B and C programming languages. Really know their stuff. Go, a statically typed compiled language often described as C for the 21st century. It's a popular choice for high-performance server-side applications, and is the language that built tools like Docker, CockroachDB, and dgraph. It was created at Google in 2007 by legends who really know their stuff, like Ken Thompson, the inventor of the B and C programming languages. Version 1.0 was released as open-source software in 2012. It was designed for simplicity and efficiency, and that's why we call it Go and not Golang. The source code is compiled down to machine code, which means it generally outperforms interpreted languages, but it's famous for its extremely fast compile times, made possible by innovations to dependency analysis. And even though it's a statically typed language, it performs type inference to deliver a syntax that is very concise and practical. It also has a package and module system, making it easy to import and export code between projects. To get started, install Go and then open an empty directory on your system. Create a file ending in .go, then add package main at the top to create a standalone executable. Then declare a main function, which is where your program will start executing. Go has a standard library of core packages to handle common requirements like math, networking, or formatted I/O. By importing FMT, we can print a line to the standard output, then run the go build command, and it quickly compiles the source code and dependencies into an executable binary. When it comes to dependencies, we can also link to remote packages on GitHub. Run go mod init from the command line, and that creates a Go module file that enables dependency tracking. Syntactically, Go is like a concise version of C or C++. Declare a variable with the var keyword, followed by its name and type, and initialize it with a value. Or you might use the short assignment syntax to replace var, and let Go automatically infer the type. And you can define multiple variables from a single line. Go has all the other features you would expect in a programming language, like arrays, maps, loops, and control flow, but also allows you to store the memory address of a value using pointers, while disallowing pointer arithmetic, which often leads to dangerous and unpredictable behavior. In addition, it supports concurrency with Go routines, which are functions that can run at the same time as other functions by utilizing multiple threads on a CPU. This has been Go in 100 seconds. Hit the like button if you want to see more short videos like this, and check out the full article to write your first 100 lines of Go on Fireship.io. Thanks for watching, and I will see you in the next one.
With Google Workspace, you can create a Gmail account with your own domain and...
All right, today we're going to learn some Go.
All right, so Melky, let's see what you got. I got about, how many videos? 1, 2, 3, 4, 5. I've got 5 videos in this series that I'm going to go through and stuff. So these are just the fundamental videos I want to go through. And at some point we'll switch over to start building some like little projects like APIs. But and then we'll probably have to go back to documentation here and there and stuff as well anyway, but that's just the natural process of learning. So let's go see what you got, Melky.
Every time I stream myself writing Golang over at twitch.tv/Melky, I get a bunch of questions from new people or people going to Golang asking, what resources should I learn? What's the best course you can recommend? Melky, how did you learn Golang? And today I'm going to give you guys my opinion on how I would learn Go if I were to start over. These are some great resources I'd recommend, and these are the ones I did when I first started learning Go. The first one has to be a tour of Go. Everyone should recommend this as the very first thing you go if you want to learn Go. It goes through basics, it goes through maybe some more intermediate, and touches on advanced subjects and topics of the programming language. You can see here, you have an interactive editor here. Package main tells you the format of a Go file. You can click run here, and there you go. Hello. It gives you everything you need with nice explanations of how to use. You can choose your language. You can go offline, whatever. You can start with package variables and functions, flow control statements, for, if, else. You can see here, it gives you a great description of everything with some code to go with it, and you can continue continue and go through all the modules, all the chapters. I love it because it gives you snippets which are easy to digest, a nice piece of code that goes with it, which you can really wrap your head around behind the concept and the practical application and how it impacts your editing. There's about 7 different modules here in Tour of Go. I highly recommend them if you've never touched them. Another one I highly recommend is Go by Example. Go by Example is, as it says, a hands-on introduction to Go using annotated example programs. Check out the first example or browse the full list below. Now, this list is a lot. There's quite a bit here. If you have the time and you want to get serious about Go, start from the beginning and go through each example. You can see here, it follows the very similar format of Tour of Go. Not going to take you a lot of time, especially the beginning ones. If you are already a programmer and you've programmed before, this will all be easy for you. It's introducing yourself to the syntax, how to create for loops, the concept of a while loop in Go, and then it dives deeper into more advanced topics and very particular Go topics like structs, interfaces, concurrency patterns, how generics works in Go. All of that is described here for in Go by Example. I highly recommend it. Even in the defer function gives you more description, breaks it down to how everything's written and how the code is executed. All right, so you may be thinking to yourself,
Well, I've done the tours and the worlds and the whatever by Go.
I need something more, Melky. Give me something better. If you are serious about Go and you've learned the syntax to a degree and you can execute a main.go file, this is your next stop. This is called Effective Go. This giant mono repo of a blog post was written in 2009 by the core Golang team, and it covers literally everything there is to cover in Go. The purpose of Effective Go isn't to teach you the concepts of for loop, else statement, or even concurrency. Effective Go tries to teach you how to think like a Golang developer and really adopt the patterns the Golang core team want to implement through this logic. It explains different control structures and gives you an example. In Go, this blog post really goes in depth with some of the concepts that those previous examples only touch on. For example, defer. Go is the first statement schedule a function called deferred function to be run immediately before the function executing the defer returns. It's an unusual but effective way to deal with situations such as resources that must be released regardless of which path a function takes to return. And it gives you an example here, and it goes more in depth with some situationals and style choice that you can go with the defer function. It also talks about data and how structs really encompass the data pattern of Golang and how structs could be used, how to run methods off of structs. This whole article goes into depth, but a really good snippet of this blog post is where it talks about concurrency. Concurrent programming is a large topic, and there is space only for some Go specific highlights here. Only one Go routine has access to the value at any given time. Data races cannot occur by design. To encourage this way of thinking, we have reduced it to a slogan: do not communicate by sharing memory, instead share memory by communicating, which really highlights how this article and blog post should be used. All these different components that may not be unique to Golang, but the way they want to be utilized by the Go core team is very much highlighted here, and I really recommend read Effective Go. Another good resource to learn Go is to subscribe to my channel. We're almost at 20,000 subscribers. Thank you guys so much for your support, but I always post Golang content, Golang tutorials, different ideas, different packages talking about Golang. So if you consider it, would mean a lot to me. All right, now if you're interested in textbooks, I recommend to actually build applications. There's 2 that come to mind, and they're both by Alex Edwards, and they're actually both part of the same series. The first one is called Let's Go, Learn to Build Professional Web Applications with Go, and there's Let's Go Further, Advanced Patterns for Building APIs and Web Applications in Go. If anyone has done and read these textbooks, they will only say good things about them. This was one of the core textbooks I've read to really help me understand how Go is used. The principles that Alex Edwards here highlights are phenomenal, and they're just really good to go through. They're big, it's a textbook. There's lots of pages. I think Let's Go Further is almost 500 pages, but they are so worth it. If you break down every module, kind of tackle it down. These are, recommendations 1 and 2 for textbooks when it comes to Go and building web applications, APIs, middlewares, area handling, all of that. These are the great resources for you. Another really good way to learn Golang is to listen by the talks from one of the creators and founders of the programming language, Rob Pike. See, I really like Rob, and I really like his presentation skills, and have an example here from Google I/O 2012. So this is 11 years old, where he talks about Go concurrency patterns. These talks that Rob does are phenomenal. They're great tidbits of information, and you may be thinking, well, 11 years old, this must be outdated. Same with Effective Go. These must be outdated resources. They're not, because Go world doesn't move that fast. Sure, there's small ifs and gotchas between, you know, a blog post from 2009 and how Go 1.22 looks like, sure. But all in all, the main points, the main concepts that these resources teach stay true. And I think these are some of the best resources to learn if you want to be a good Golang developer. So I hope you all enjoyed this video. Let me know what you think in the comment section below. Did I miss one? Did you think there should be one that could be added? Let me know. And as always, you gotta power it.
Nice one, Matthew. That was a great video. That. I will definitely be checking out the first three in that when the time comes on.
That into this to do. So I'll just say c dot body parser and
so
learn the basics
this is 2 hours long. We're definitely not going to get through all this, so we'll just fashion in for the first hour and a half and see how it goes.
of Go by building a full stack web app with React and Go. The project also features TypeScript, MongoDB, and Chakra UI, and you'll use TanStack Query to implement data fetching, caching, and updates. Barak from As a Programmer developed this course.
when you start learning full-stack web development, you'll probably go with Node.js and React because it is really convenient to build full-stack apps by just knowing JavaScript. But after a while, it can feel a bit repetitive, so you'd like to try out something new. And probably that's why you clicked to this video, where we will
It's not really the reason for me. I do want to try something like new, which is like learning a new language, more to like broaden a skill set. And I think there's cases for where I want to use Go instead of Node.js by default and stuff. So just time to
build
skill
a
up.
full-stack web app with React and Go, and we will implement all CRUD operations, which are create, read, update, and delete. And you will see the entire process because I will take you from an empty folder to the deployment. And today we will build a task app where we can create one, mark as completed, and delete that task. Just to make this as beginner friendly as possible, we will build the API twice. In the first one, we will store the data in memory, and then we will build it again by connecting to a database, which is gonna be MongoDB. And in the front end, we will use React with TypeScript. We will use TanStack, also known as React Query, for data fetching. We will use Chakra UI for styling, and at the end, we will deploy our app to Railway for free. So overall, a simple but yet effective tutorial to get you up and running with your very first Go application. I had a lot of fun while building it, so I hope you will like it too. And I would appreciate if you could leave a like and subscribe. Thanks for watching, and let's get started. So before we start coding, if you visit the GitHub repo that you could find the link in the description, you will see this file called comparisons.md. So I know that most of you guys has the JavaScript background with Node.js, so I wanted to create this kind of like notes or cheat sheet that you could use before starting the tutorial, or maybe after completing it. I think that would be kind of like a cool comparisons that we could do in the Go environment and Node.js. So in Node.js, when you start to create a new project, you would say npm init, which will give you a package.json file, and the equivalent of that, I'll just zoom in a little bit, in Go is going to be go mod init, and then you would put a module name. So this is going to be some kind of like unique identifier for your module, and it is going to create a go.mod file in the current directory. And again, this is going to be that kind of like package.json file which contains information about the module, its dependencies, and the Go version that you're using. And this module name has like, it could be anything, but it has a convention, and we'll see that in a couple of minutes. And then when you want to start your application in Node.js, you would basically run this kind of like a command, which is npm run start, and in Go you would say go run and then the file name, which is going to compile the program and executes it. And then when you want to install a package, you would say npm install and then package name in Node.js, and in Go you would say go get and then the package name. So go get is not a package manager, but it is used to download and install packages from remote repositories, and it does not handle versioning, and this command fetches the package and its dependencies if there are any. And then, as we just talked about it before, package.json, the equivalent of that would be go.mod file, which contains the information about the module, its dependencies, and then the Go version. So when you want to install all dependencies in a project, you would say npm install, and in Go, that's going to be go mod tidy. And then when you want to stringify JSON, so you would call this method, and in Go, this is called something like marshalling. So you would say json.marshal, and you're gonna have so like the Go data structure, and when you just marshal that, it's going to stringify it to a JSON string. And the reverse operation is gonna be json.parse, which is gonna be unmarshalling. So again, you have a JSON string, and you're gonna run this method with that, and it's gonna give you that Go data structure in JSON, right? Now this code might look a little bit complicated, but we'll get to that. And then the nodman is something that just reloads your application whenever you change some source file, right? That's going to be in the Node.js. And in Go, there is Air, which is a live reload tool, just like nodman, but in Go applications. So it's going to watch for file changes and automatically rebuild and restart the application. It is similar to nodman, and there are other alternatives like Fresh, but for my case, Air was the most convenient one to use it. And to be able to configure it, you need to have a file called air.toml, and this is something that, again, we'll just get into that in the video. And so to be able to store your environment variables, you would install the .env package in Node, and in Go it is going to be this go get and then the module name, so github.com jaho and then go.env. And again, this is going to allow us to store sensitive information like API keys, database URIs, and any kind of like secret. And here is an example of that, where we just you say go.env.load the env file, and if there are any errors, just console log it to the console, right, or in the terminal. But if we just pass that, now we could just get any environment that we have, and we're going to just assign it to a variable. Now we would use Express.js in Node, assign it to a pass that. Now env.load the env file, and if there are any errors, just console log it to the console, right, or in the terminal. But if we just pass that, now we could just get any environment that we have, and we're going to just assign it to a variable. Now we would use Express.js in Node to be able to have that web framework, and in Go it is going to be Fiber, which is a web framework for Go, and it is inspired by Express.js. So it is fast, lightweight, and easy to use, and you're going to see it is actually looking pretty similar to Express. And there are other alternatives such as Gin and Eco, and if you wanted to, you could take a look at them after completing this video. Then let's see a middleware. So in Express.js we had middlewares, right? This is actually a concept that we have almost in any kind of programming language when you build an API or something similar. And in Go, here is how we would use it. So we create an app just like in Express, but we say fiber.new, which is going to give us an instance. Then we would mount the middleware to our function, and that middleware is going to take the next as the first argument. And once we have run the middleware logic, it's going to call the next function. So that's going to be the middleware. And then we have route handling, and here is an example, the equivalent of that in Go. So you would mount your route and your handler or the controller function, and that's going to take the context, and you could just send a response, and we'll be using that in the video as well. So that's going to be my comparisons. I think that's a pretty cool list, which is about 200 lines of code that you could use it after completing this video as well. And with that, let's go ahead and initialize a Go module. So here we'll just say go mod init and then the module name. So here is my empty folder that I have just created, and I'll open up a new terminal, and I'll say go mod init, and then we could just put anything here, but the convention is to put your GitHub repo that you will push this into. So I'll say github.com and my username, then I'll just say React Go tutorial. And this is going to be the repo that I will create and push this code into. And if we just press enter, that's going to give us go.mod file. Here we can see this is the Go version that we are using, and this is the module name. And to be able to use Go, I forgot to mention, but you need to install Go in your machine, which is pretty simple. You would just go ahead and Google it, then just install it and just press a couple of next buttons, and it should be fine and up and running. So in Go, we have like packages and modules, and let's just see that on a diagram. So here is our note about packages and modules. So a package is a collection of Go source files that reside in the same directory. So here, let's see, this is, let's say, a package, right? And we have the main.go. So let's say that's going to be our main package. Then we have the handlers package, the API package, so on and so forth. And all of them coming together is going to form a module, right? So packages collectively form a module. And when you initialize a Go module, so basically you are creating a module, right? Because it's gonna have multiple different packages, and like it's gonna form a module. So the very first thing that we'd like to do is create a main.go file, and this is gonna be the main package. So we'll just say package main, and this idea is kind of like different if you have never used it. But once you just write a couple of different lines of code and use it more than, so let's say you would use it in a couple of different projects, that's going to just make a lot of sense. So here, this is going to be our main package, and in the main package, you have to have the main function. So here, Copilot is getting a bit annoying, so I'll just go ahead and disable completions. So here, I'll just have my main package, and I'll just, let's say, console log hello world. For that, we would use fmt. Let's import that, and I'll say fmt print line, just like this, and I'll say hello world. And to be able to run this file, I'll just say go run and main.go. Now we should be able to see hello world in our console. And let's see the variables in Go. So I'll just shrink my terminal. Now there are a couple of ways of creating variables. So with the var, we have, let's say, my name, and type is going to be string. So I'll just say John Doe. And there is another usage with const. We'll say my second name. That's going to be string, and we'll just say Jane Doe. So this is not going to be a Go complete crash course, but I just wanted to talk about variables for a second, because there is another way of using that, which is pretty common, where you don't really declare the type, but that's going to be inferred. So I'll just say my third name, and if I just put this colon and equal sign, I could just say, let's say Bob Doe. So here, this type is going to be string by default because it is being inferred, and I'll be using this kind of variable assignment a lot in this video. And if we just say fmt.print line my name, let's say duplicate this one twice, I'll say my second name and my third name, we should be able to see all of them in the console. Let's go ahead and run this file with go run main.go. And there we go, we have all of them in the console. So that's going to be the variables, and just keep in mind that this is going to infer the type. I think I could delete all of them, and here we'd like to install the Fiber so that we could create our API and just have our web framework, right? So I'll open up my terminal, and I'll just say CLS to clear up my console or my terminal, and I'll just say go get. So let's get the Fiber. So I'll say github.com go fiber/fiber, and then I think it's going to be v2. Now that's going to get that and update our go.mod file. So there we go. We have all of our changes, and even we got the go.sum file, and it's going to be again related to packages or modules. And let's create our app. So I'll say just like this, it's going to infer the type, and I'll say fiber.new, and we would like to say app.listen, and now you would put column and then let's say the port, which I'll go with 4000, and that should be capitalized. And if we have any errors, we could just wrap this with, let's say, log and import the package and fatal. So with that, we should be able to see any So if you hover over this, it's gonna say fatal is equivalent to print followed by a call to OS exit 1, which means there were some errors. But if we don't have any, I think that's gonna work fine. Let's go ahead and run our server, right? I'll say go run main.go, and we should be able to see the hello world, and now it is listening on our, let's see, this port. And here we are getting this kind of like security kind of thing. I'll just say accept the, so just let me use the go. So now whenever I change anything in this file, so let's say hello world s, it is not going to restart my server. To be able to see that change, I need to kill it and then just restart it again. So now I could see it just has the new update and like the thing in the console, but I don't really want to have this. I just want to have that kind of like node mom feeling where it's just going to restart that as soon as I change anything in this file. And for that, I'll just go ahead and kill my terminal, clear that, and install a package called air. So I'll say go install and then this github.com and just paste it and press enter. And once you have done that, it's going to install air where we need to create a file for the configuration. So go into this like file explorer and just create air.toml. And to be able to get this kind of like formatting, install this extension in VS Code. So it is this one that I'm using to be able to get this kind of like the formatting that you'll see in a second. Now this is a file that I have prepared with the help of ChatGPT and taking a look at from the Stack Overflow, and I put some comments for your convenience. So here we just say the root file is going to be this current directory of the project, and the temp directory that you'd like to store your files is going to be temp, which is going to be created whenever we run the air command. And here are some build configurations. So we're just saying include any Go file, just watch that changes, and exclude anything in the client and in the temp. And we don't have the client, but we'll create that when we add our React application. And here we have a couple of different commands that you could take a look. So it is not really important, and let's kill it. I will go ahead and just say air. And here we can see it has been created, and now it listens for our server. So now anytime I just do some change, it is going to actually restart it because it says main.go has changed. So it's gonna build and it's gonna run that. Here we can see the updated result. So we don't really need to kill it and then just restart it again. Now let's go ahead and add our first route. So here I'll just say app.get. In the root route, we would like to call our handler function. So I'll say func, which is gonna take the context, and you'd like to call it as C. This is the convention, and that's going to be fiber.context, but that's going to be a pointer into that. So I'll explain the pointers in a couple of minutes. Most of you guys know how that works, but in case so like some of you don't know, I'll just try to explain it pretty quickly. And we'll just say we might want to return some errors, so we're going to put that, and we'll say return, let's say c.status of 200. And we'll just say, let's see, this is not correct. Okay, c.status 200, and the JSON data we would like to send, let's say fiber.map, and we'll just say message is gonna be, let's say hello world. And to be able to test it out, let's go ahead and install this Postman extension. Feel free to get that. I think it should be this one. Okay, instead of using this desktop application, we're going to use it directly in the VS Code. I'll just zoom out a little bit, and I have a workspace called React Go Tutorial, and I would like to add a new collection. I'll just say to-dos, and I'll just create, let's say, add a request. That's going to be a get request, and I'll just say maybe get to-dos for now.
This is Julia, right? Yeah, I'm learning. This is my beginning journey for learning Go. I want to do something a little bit fresh this year, so I was going to pick it up to do back-end development instead of just deferring to Node.js all the time, so this is the beginnings.
Now let's call it like that. And our endpoint is going to be HTTP localhost, and our port is 4000, and we would like to just send a request to the root route. And if I just send that now, it's going to say hello world, because this is what we are sending. So now that we have this kind of like boilerplate setup where we have our application, we are listening on this port, and we are just having this kind of like handler function, I think we are ready to go and build our the first part, right? So we're gonna store to-dos in the memory. That's gonna be the first part, and then in the second one we're gonna actually connect to MongoDB. So here we're gonna have a couple of different to-dos, and for that we could use struct in Go, and which is going to allow us to have custom kind of like data structure where we could give different fields with different data types. So I'll say type, which is gonna be to-do, and I'll say that's gonna be a struct, and open up this curly braces. So each to-do will have an ID. Let's say the type is going to be int. That should be a lowercase, and we'll say completed field is going to have, which is going to be bool or boolean, and we'll say it's going to have a body, and which is going to be type of string. And in the JSON body, we would like to just rename them. I'll just say JSON and open up this quotes, and I'll say ID, and I'll do the same thing for this one, backticks JSON, and that's going to be, let's say, backticks completed, and this is going to be the value that you'll actually see in the response. So JSON body, and that's how I would like to call it. So I'll just save to get this formatting, and now in the main function we would like to have the to-dos array. So I'll say to-dos and assign it to, let's say, just like this. I'll say it's going to be to-do but an array of it, right? So just like that. And the very first thing that we would like to do is actually create a to-do. So I'll say app dot post. So that's going to be our post method, and our endpoint is going to be API slash to-dos. We would like to have this function, which is going to take the C, and it's going to be pointer to the fiber dot context, and this function might return errors. So we're just gonna put that error and just have our function body. So we're gonna have a to-do, right? Let's just say to-do is gonna be equal to this to-do struct that we'll have. Now this is gonna give us, since we didn't pass any value into it, it's gonna actually create it with the false values or the default values. And for int, it's going to be 0. For boolean, that's going to be false. And for string, it's going to be an empty string. So here, just imagine now this to-do is equal to, let me just put it in the same line. So the ID is 0, completed is going to be false, and the body is going to be an empty string. But this body or this object is going to be coming from the user, right? It's going to be coming from the request, and for that we can check for it and assign it to assign that into this to-do. So I'll just say c dot body parser, and we're going to pass the to-do. So if you take a look at that, body parser binds the request body to a struct. So it's going to take the whatever user sends from the request and assign it into this to-do. But now this should be a pointer, so we need to just say get the memory address of that, and this might return us a error. So I'll say if error, just assign it into that one, and just put this where we'll just check for error. So we'll say if error is not null, which is equivalent of null in JavaScript, and we'll just say return the error. So here this looks a little bit weird, where we create the error in the same line and just check for it. We are assigning the value and check for it, right? And then we'll say users can create the to-do, but what if body is an empty string? Then we'd like to return an error. So I'll say if to-do dot body is equal to an empty string, then I'll just say return c dot status of 400, and I'll say JSON, where I would like to say fiber dot map, and I'll say error field is gonna be, let's say to-do body is required. Okay, but if this is not the case, we can increment the ID by 1 because it was 0 where we have the false values, right? So I'll say todo.id is going to be the length of to-dos plus 1. And we'll say now to-dos, we'll like to append the current to-do that we have just created. So I'll say append, call this method, and we'll say into the to-dos, add the new to-do. And since this is the memory address, we'll like to get the value out of it, right? That was the pointer. And eventually we'll say return c.status of 201, which means a resource has been created. And we'll say JSON of to-do. So now let's save, test it out, and then I'll explain this kind of like pointers. And I will duplicate this request, and I'll say create a to-do. That's going to be post request. I will save that, and our endpoint was /API/todos, where we'd like to send the to-do body. So let's go into the raw JSON, and if we don't pass anything, that should say okay, this is giving us an error. Let's see what is the problem. Maybe opening up our console. So I'll just, I think, save that one and send it again. Okay, I'll just say body is gonna be hello world. Okay, it says now it's been created, but if we don't pass anything, it's gonna say to-do body is required. And that means our endpoint is actually working. We sent a request to there in this function run where we check for the errors and eventually either return the response or the error. And now let's take a look at these pointers. So here, let me just explain that here, and then I'll just show that in a diagram. So let's say I have a variable, maybe I'll just zoom in a little bit. So here, let's say I have a variable called x, which is type of int, and let's say the value is 5. And then this is going to be stored in a memory address, right? So let's say it's going to be 0x000 and maybe 1. So this is the memory address of x, and the value of it is 5. And let's say I'll have a pointer now, and that's going to be int. And just to make sure that this is a pointer, we need to put this asterisk before that int, and I'll say this is the pointer that points to the memory address of x. So that's basically it. This is the memory address of x. So the value of p is now actually the memory address of x. Okay, so this is the value that p stores, and the value x stores is 5. So if you just say now fmt print line of p, then you're gonna actually get this value. And if you say p, but the address that the value that it stores, it is gonna give you the value of x, which is gonna be 5. So I hope you're able to see how that works. P stores the memory address of x, and when you ask it like that, it's gonna tell the compiler to give the value that has been stored on this address. So that was kind of like so strange idea if you're seeing this for the first time, the pointers. So we have a memory, and let's just see that on a diagram. So we have just created a variable called, let's say, x. The value was 5, and let's say this has been stored on this address. Okay, so this is x, the value of 5, and then we have created a p, which is pointer, and it is gonna point to the, so it's gonna point to the x. So here we have the p. For the value, it is gonna get the memory address of x. Let me just mark it like that, and there you go. Now if you say, hey p, give me the value of this address that you are storing, then you would just say asterisks, so asterisk and p, which is gonna give you the value that has been stored in this address, which is gonna be 5. And here, this is the kind of like what I've explained. And here we got the memory address of that to do, and we're getting the value out of it. And this is how it works in Go. So kind of like strange, but once you're used to it, it gets it just makes a lot of sense. And so we have created the to-do endpoint. So I'll say create a to-do, and let's try to update a to-do. I will delete this line, and below that I'll just say update a to-do. So for updating, we could use the put method, but I think I'll go with patch. So it's just preference. Feel free to use the one that you'd like to use. And I'll give the endpoint of /API /todos / the ID of to-do that we'd like to update. So that's going to take the handler function context. So let's say fiber.context, and we could return an error. And we'll just get the first ID from the params. So I'll say ID is equal to c.params, and our params is called as ID. Now this is going to be type of string, right? So this is something important to keep in mind. And we're going to first for loop our to-dos that we are storing. So I'll say for I, this is going to be the index, and then the to-do itself, where we would like to say range to-dos. And this is how we would run a for loop in Go, and Go doesn't have while loops, so you need to write them in for loop if you need any. And here we'll just go ahead and say if to-do dot ID is equal to the ID that we have in the params. But now this is going to give you an error, because this is the type of int that you are storing, right? And this is the type of string. And to be able to make that work, we can convert this to-do ID to be a string. And I'll just say fmt dot sprint to-do dot ID. Okay, with that should be fine. And we'll just say to-dos I, so it's gonna find that in the completed field. We're gonna just make that to be true. So if you want to negate it, so you would say just get the current value. So I'll say to-dos I completed. So it's going to either make it true. So if it is true, it's going to be false. But if it is false, it's going to be true. But in this case, I just want to always make it true when I send in request to this endpoint. And once this is done, I'll say return c.status. Let's go with this one, 200. And we could just return the updated to-do. So I'll say to-dos and the index. But if this is not really the case, we're going to say to-do is not found. So return c.status of 404. And let me just scroll a little bit. And I'll say send maybe just JSON fiber.map. So to-do not found. Let's go ahead and test it out. I'll create another one. I'll duplicate this, and that's gonna be patch. So API to-dos, and let's say you'd like to update the first to-do that we have created. And by the way, let's create a couple of different. So I'll just say learn React, send it. So it is not completed. So let's say learn JavaScript, learn Python, and let's say learn Go. And here you can see ID is just incremented by 1. So we're gonna go here, and we don't really need to pass any body. So if you just save that, it's going to update this method name. And if I just say update the first to do, it is gonna make it to be completed. So there you go. It is learn React, where we have the completed field to be true. And by the way, whenever you kill your server terminal, it is going to actually delete every to-do that you have, because it is storing that in memory. So this is something to keep in mind when you're working with in-memory kind of like approach. So okay, I think that's gonna be it for the update a to-do endpoint. Let's go ahead and create the delete one. So I'll say delete a to-do, and that should be our very last endpoint. So I'll just save that first and scroll a little bit. It's going to be app.delete. our endpoint /API/todos and then /the ID so that we could know which to do that we are deleting. And also, I think I forgot to update this one, which is going to be to be able to get all to-dos. So that's going to be /API/todos. And let's go ahead and update that one. So here we had the root route, and I'll just make that to be /API/todos, which is going to just return to-dos that we had, right? If we save, and if we just send a request to that, let's just see, send it again because it was restarting. Okay, let's see, what is the problem? So it says missing handler in route. I think we forgot to, let's just comment this out. Since we don't have the handler function, it just throws us an error. So I'll just save that, and in the get to-dos, we should be able to send this request, and we cannot get anything. Let's just send it again. Okay, there we go. Server just started and it says hello world, but we don't really want to get that. So if we hit /API/todos, okay, looks like it is not really working. I'll just go ahead, kill the terminal, clear my console, and I'll just say error. And if we just test it out again, so for some reason there was some kind of like caching problem, so I just killed all of them, right? And then I open up like get to-dos, and now if I just send a request, there we can see we don't have any to-dos in the response. So I don't know why did we got that kind of like caching, but here you can see this is the exact same code that we have just written. So let's go ahead and try to add this delete to-do handler. And again, this is going to be pretty similar. So we'd like to have this kind of like handler function, which is going to be the pointer to the fiber.context. You might want to return an error out of this function, and we're going to get the ID from the prems. So I'll say c.prems, which is going to be the ID in this case that we that's how we have called it. Then we're going to say for I, the index, and then the to-do in range of to-dos. So we're going to find the to-do that we would like to delete. So I'll say if to-do.id is equal to ID, and again we're going to get that error because this is the type of integer that's how we have created in the struct, and we need to and this is like type of string, so we can't really compare a string to a number. So we need to convert this to be a type of string as well, just like we have done previously. So I'll just say fmt.sprint and just wrap the to-do ID with that. And if this is the case, we'll just say to-dos, and we're going to just reassign it. So I'll say append into the to-dos up until this index that we are trying to delete, but not including. And we're going to say to-dos, just add these values, so I +1 and up until the end, and we need to put this 3 dots, which is going to just unpack those values. So let's say if you didn't understand this code, let me just show an example. Let's say you had 5 different to-dos, okay, and we have just wanted to delete the third one. This is gonna say that just take the first 2 values, right, up until the index but not included. So we wanted to delete this one. It is going to take all of them, but not this one included. So now we're going to have 1 and 2, not the 3, and from I +1, so starting from here up until the end. So we're going to have 4 and 5. There you go. We have deleted the third one, and this is the new to-do list that we have. So I hope that makes sense. And this is something called variadic operator, and it is kind of like this spread operator in JavaScript where you just unpack the values. And we'll just say return c.status, and let me just actually copy that line and paste it because it is pretty similar with the status code, and success is going to be true. And if this is not really the case, we couldn't find anything, so we'll just say return 404 JSON fiber.map to-do not found. Let's go ahead and test that out. So I'll just go ahead and maybe add a new request. That's going to be the last one, and I'll just make this type of delete.
Some
save that,
interesting
and I'll
pieces
say
of syntax.
delete a to-do. Okay, I'm gonna save that and I'll say this is gonna be my endpoint /API /to-dos and then the ID of the to-do. First, if we try to get all to-dos, we don't have anything in the memory, so let's go ahead and create one. So I'll just say learn Go, and let's create two different one. So I'll say learn React, and let's say learn Python. Okay, so we have created three different to-dos. If you want to get all of them, here you can see we have three different items, and I would like to just delete the learn React. So I'm gonna put the ID of 2. There we go, it says success true. And if we want to get all of them, here we can see the ID of 2 has been deleted. So with that, I think that's gonna be it for the first part of the course, where we have just created 4 different endpoints to be able to get to-dos, create a to-do, update one, and just delete one. And we are listening on a port, so everything works fine. And next, we would like to actually write this same thing, but with MongoDB, where we could have a database and just store those values. So when we kill our terminal or when we kill our server, we don't really lose them because they're not going to be stored in the memory. And before we get into that, let's just see how we could use .env in this Go application. So the very first thing that we need to do, just maybe kill this terminal and just say CLS to be able to clear that. And I'll say go get github.com/ I think it is called as Joho, and then we'll say go.env. And if we press enter, that should get us that module, and we would like to load environment variables. And for that, let's go ahead and create this .env file. And I'm not sure if you have realized, but we have this temporary, so kind of like the folder where the air is going to create whenever you run this air command. So it's gonna, depending on your changes, it's gonna store its files in this temp directory, which is going to be the executable of the compiled code. So in the .env, let's say I have my port as, let's say 5000, and let's delete this spaces. And instead of using this kind of like hard-coded value, I could just use that port. So the very first thing that I wanted to do is just scroll to the very top, and I'll just say error and just assign it like this. I'll say go.env.load the .env file, and if error is not null, which means there is an error, right, we need to catch it and just say log.fatal, and let's say error loading .env file. But if this is not the case, I'll just put this port variable and assign it to OS. Let's import that. Make sure you have
Wonder when it is that you decide that, how you tell when something can return an error, or whether it's like an optional thing that you can do. Just wondering about
imported
that.
all of those modules and packages.
I like the fact that you undo the errors first.
Get env, and we have called it as port, right? And now we could use this value actually in here. So I'm gonna delete that, and I'll say plus port. So we have called it as 5000, right? Let's see if that's gonna work or not. I'll call it and delete that, and I'll say actually we have called it as port, right? And now we could use this value actually in here. So I'm gonna delete that, and I'll say plus port. So we have called it as 5000, right? Let's see if that's gonna work or not. I'll just clear my terminal, and I'll just say error. And there we go. Now I can see the hello world, and I can see my server just started on this port, which is 5000, right? Okay, so that's gonna be it for this very first section. Let's just initialize this as a Git repo and commit our changes. For those of you that want to see in the commit history, the first version that we have created completely in the memory, and next we're gonna build it with MongoDB. So I'll go ahead and maybe just kill this terminal. I'll just say clear that, git init. Initialized an empty Git repository. Let's create a git ignore file. So I'll say .git ignore, and the content that you could just grab that from the GitHub repo. So this is something that I just wanted to paste instead of writing it from scratch. Okay, so here we're just excluding the compiled binary files, macOS specific files, .env, not modules, and all these files that are not really important to be tracked by Git. So if you save that, here you can see this has been ignored. This file should be ignored, and yeah. So let's go ahead and add all of them to the staging area, and I think I'll just give the first commit as first section completed, store in memory. So I'll just commit those changes, and I'll see you in the next section. Okay, so in this section, we're gonna build this exact same API again, but this time using MongoDB.
Check out this guy quickly. Wow, he is making stuff on here, I tell you that. Yep, he is working on this. Good to see. Trying to figure out what his name is again. No. Wow, really good. He's building stuff. This is where we're going to get to at some point, where we're going to get to, so keep working at it. Loving the course so far, man, so thank you very much.
MongoDB so that we could see how we can interact with a database. So the very first thing that we'd like to do is just visit mongodb.com and create an account for free, and then just log in. And once you log in, it should take you to this dashboard where you can create an organization and then create a project. So I'll just say create a new project, and then I'll just give a project the name. So I'll just say Go, maybe React Go tutorial. And I'll just say next. Project owner is going to be me, so I'll just say create the project, and then I'll just create a deployment. And I would like to use the free tier, which is enough for our side project, and cluster name could be just default, and let's say create the deployment. And here we can see the username and password, so you would like to copy this and don't lose it. So I'll go ahead and just paste it in the env file for a second, and we're going to be using that. So I'll just say create the database user, and once we have done that, it's going to say choose a connection method. So here on the screen there is my IP address. You can't really see it because I hide it while editing this video, but you should be able to see your IP address, and it is going to add that to enable local connectivity. And let's say choose a connection method. We would like to connect to, let's say, from our application. So I'll just go ahead and copy this string and then just paste it to here, and I'm gonna give or maybe I'm just gonna assign it to this variable. I'll say mongodb underscore URI. Okay, there we go. And here there is my password, so I don't really need this one. I can delete that. And with the help of this environment variable, we're able to connect to our MongoDB database. So this is our connection string. And once you have done that, let's say review setup steps, and let's say this is done. So now you don't really want to get some development errors. So just go ahead and go into the network access, and here you can see there's going to be your current IP address, but let's just add the IP address where we could just access from anywhere. So I'll just click this one, which is going to be this IP address, and I'll say confirm. And it is in the pending state. In a couple of seconds that should be active. Okay, there we go. Now it is active and we can visit our database, and currently we shouldn't really have any collections, but in this case we have one, and this is something MongoDB gives you out of the box so that you could do some testing. But in this case I'll just go ahead and delete that.
Waterhouse Gardens is one of the most exciting projects Manchester has ever seen. Located in the
skip all the ads.
And currently I don't have any databases or any collections, but we'll create in a second. So we'll like to interact with our MongoDB database, right? So we need to use the MongoDB driver. So I'll say go get, and I'll just put that as lowercase. So go.mongodb.org/mongo-driver, and I think /mongo. So just type this and press enter. That's gonna get you the Mongo driver so that you could interact with your database. So I think I'll just delete this file completely, except from this type. I'll just cut that and select everything and just delete it. Okay, I'll say package main, and I'll say func main, and I'll just say fmt print line, where I could just see the hello world in the console. And then I'll just paste my struct at the very top. Now this is going to be exactly the same, but we'd like to add one more field, which is going to be bson for the ID, and we're going to say _ID and just leave it like that for now. And we need to add this field because MongoDB stores its data in the format of bson, which is also known as binary JSON. And this is the data format that MongoDB uses. So this is something I think required that you need to pass. And then let's say var collection, where that's going to be a pointer to the mongo.collection, and make sure you import this package. And now we'd like to actually load the environment .env file, and let's just say that. So error, we'll just say go.env.load.env, and if there is an error, so if it is not null, then log.fatal, let's import the log. So here we'll just say error loading.env file, and you could even put the error message. And then we'd like to have that MongoDB URI environment variable, and we'd like to just grab it from our .env file, right? So I'll just say os dot, let's import the os, and get env, and let's see what we have called it. It was MongoDB _URI, and I'm gonna take this value and just assign it to a variable. So I'll just leave it like that, and I would like to be the type to be inferred, which is going to be type of string. And then we'd like to connect to MongoDB. So we're going to say client options. This is going to be our variable. So I'll say options, and we need to import that as well from Mongo options dot client, and then we'll say apply URI, where we'd like to pass our MongoDB connection string. And then we're gonna get the client and error out of this call. And again, let's infer the type. I'll say mongo.connect. And now this want you to, if you just hover over that, this want you to pass this context, right? So I'll just say context dot background. So this is not scope of this video, and this is basically something that you would like to create when you want to have maybe some cancellations, some timeouts, but in our case we don't really want to have it. We just say, so it is like saying I am starting this task, but I don't have any special requirements or deadlines attached to it. Okay, so that's going to be the information about context. This is just something that we need to pass. You could ignore it for now, and we're gonna get the client options. And again, we'll say if error is not null, so error is not null, and let me just scroll a little bit. If it is not equal to null, we're just gonna say, let's say log.fatal, the error itself, and then we can just check the connection with the ping method. So I'll say again an error, I'll say client.ping, and again this want you to pass a context, so I'll say context.background, and make sure you have imported this context package, right? Then here I'll just put the second variable as nil, which is readpref, and we don't really need to pass it. And let's see, why do we have this error? Okay, if we just delete that, that should be fine. And we'll say if again error is not null, let's just do the same thing just like this, but otherwise we'll just say fmt.println connected to MongoDB Atlas. So just like that, and let's save this and just test it out. I'll just clear my console and I'll say error. So it just run that, it says hello world, and then it connected to MongoDB Atlas with the help of this methods and this kind of code block that we have just written. And now we would like to have a database and then a collection. So for that, for my database, I'll just go before this question mark and I'll just call it as Golang _db. And this is going to be the database that I would like to connect to. So here I'll just go ahead and say collection client.database. Oops, it should be database like this. So it just auto completes my code, but I think if we delete this part, it should be fine. Just leave it like that. Client.database, we will have the Golang _db. In our collection, I would like to just call it as to-dos. So I'll just store all of my to-dos in this collection, and I'll say app, again, just create a fiber.new, and then we're gonna have 4 different endpoints. So I'll say app.get, right, which is going to be /API/todos. And instead of putting the function immediately here, we could just make our code a little bit more kind of concise or maybe clean. Let's say get todos, and I'll just duplicate this, I think, 3 more times. This one is going to be to be able to create a to-do. So I'll just say app.post, and this is going to be, let's say, patch, to be able to update one, and this is going to be delete. And here in the last 2 one, we would like to add an ID so that we could know which to-do we are deleting or updating. So we have get to-dos, and let's say create to-do, and this handler function is going to be update to-do, and lastly delete to-do. Then again, we could just get that kind of port from the .env file, and this is something that we have done previously, so I'll just copy it and paste it. And now we could just check if port is empty, then we could put a default value. So I think I'll just go with the 5000, and because that's what we are using. And eventually we're gonna just say listen to that port, and if there are any errors, just wrap it with log.fatal. And now let's go ahead and create all those functions or handlers. So I'll say func. The first one is going to be get to-dos, which is going to take the context. Say fiber.context, which can return us an error, and just get the function. And let's just duplicate that 3 more times. The first one is going to be create to-do, update to-do, and then let's say delete to-do. And let's comment all this out and just implement them one by one. First, let's start with this one. So here I'll just scroll down a little bit, and we're gonna have var to-dos, and that's gonna be an array of to-do, let's say, and we're gonna just fetch that and maybe assign it to that, or just append to that to-do, right? So that should be uppercase to-do because that's what we have called our struct. So we're gonna say collection.find, and we're gonna say, again, we need to pass the context. So I'll just say context.background, and the second option is going to be bson.m. So this might look a little bit complicated, but basically we are trying to pass our filters. In our case, that's going to be no filters because we would like to fetch all to-dos in our collection. So if you want to pass some filters, then you would put something into this object, but in our case we don't really want to, and we would like to just fetch all documents in that collection. And this is going to give us, let's just assign it to the variables. We're going to have the cursor and then the error. So error is going to be whatever that is, but the cursor is something when you execute a query in MongoDB, it returns a cursor, and which is essentially a pointer to the result set. So you can use this cursor to iterate over the documents returned by the query. So just think of it like we have all of our to-dos. And let's just say if error is not null, right? So we have an error, then just return that. But else, we'll just say for just map through it. So cursor dot next, and again we need to pass that context. So I'll just say context dot background, and for each to do we're going to create this variable, let's say to do, and we'll just say if there is an error, first we need to decode that, right? So I'm just gonna assign it to that error, and I'll say cursor dot decode, where we need to just put this to do, and if error is not null, then we're gonna just return the error itself. But if this is not the case, then we're gonna just append this to do into that to do's, right? I'll say append into the to do's to this to do that we have just get from the cursor, and eventually once we have get all of them, we're just gonna say return c.json, just pass the to do's. Okay, so with that should be completed for this function. But now there is one optimization that we could use. So we have just created some kind of connection, right? We are patching something, and at the end of the day we'll like to just close that cursor when this function done, right? So I'll just say defer, which is a keyword that we use in Go to postpone the execution of a function call until the surrounding function completes. In this case, this is the surrounding function, right? Once this completes, it's gonna run the right hand side. So we'll just say cursor dot close, where we'll just say context dot background. Okay, so again, defer is a keyword that you use to postpone the execution of a function until the surrounding one ends or that completes. And that was that kind of like the optimization, and we could do the same thing here when we create a connection to our database. So here I think after this mongo.connect, we could just say, maybe after the error, I'll just say defer client dot disconnect database, let's say disconnect, and again just pass the context dot background. So when this main function done with executing, right, we'll like to disconnect from that database from the client. So with that in mind, let's save this and try to test it out in the Postman, where we'd like to get all of our to-dos, and now our localhost port is going to be 5000 because this is what we have put here, right? I'll just save that, and if we take a look, it is up and running. Let's just send a request. So we got null because we don't really have anything in the database. So next, let's go ahead and add the create to do endpoint. So I'll just uncomment this and create this function, maybe shrink this one and just uncomment this one, right? So here we would like to again create a to do. So I'll just say to do, and that's going to be equal to a new to do. So again, this is going to be a pointer. So just to keep that in mind, because we will use c.body parser. So I'll say c.body parser. There I can see that. And I'll just say pass it to do into it. And again, just remember that this is going to bind the request body to a struct. In this case, this is going to be that struct. We're going to take the request body and pass that into that struct. And here we will just say if this is going to return us an error, so we'd like to just assign that, and we'll say if error is not null, right? I'll just say then just show the, maybe return the error itself. And again, we're gonna just check if body is empty or not. So user can't really create a to-do by putting nothing. So I'll just paste it. Here we just say to-do.body. If it is an empty string, then just say to-do body cannot be empty. And then we'd like to insert into the MongoDB, right? If we just pass all of those if checks. So I'll just say collection dot insert one, which is gonna take the context dot background as the first argument, and then the item that you'd like to insert, which is gonna be this to do. And that's gonna give us, let's say, give a bit spacing, it's gonna give the insert result as well as the error. So here I'll just move on to the next line, and I'll say if there is an error, and just return it. But otherwise, let's just move on with the function where we'd like to just update the to-do ID, right? Because when we created this to-do, that's going to have a falsy value. And as I have explained previously, the ID is type of int, so it's going to be 0, right? ID is going to be 0. Completed is type of boolean. By default, that's going to be the false. And the body is type of string. That's going to be an empty string. But now that we have created that and inserted, now we have the inserted result. So we'd like to just update the to-do ID with the inserted ID. So I know that sounds a little bit complicated, but here we'll just see in a second. Insert result dot inserted ID, and which is type of primitive. Let's just do this type assertion, right? So primitive, and just import it from this Mongo driver dot object ID. And I think we forgot to use this one when we initialize this to-do struct. So here we have this ID. It is not going to be type of int because MongoDB has its own ID type, and I'll just say that's going to be primitive.objectID. Okay, we just remember that. And if we take a look at here, we need to add the error, and otherwise everything should be fine. So we have just updated that, and let's say return c.status of 201. A resource has been created, and JSON just return that to do. Now there is an issue here where when we just create a to do, right? So that should have an ID, and by default that's going to be 0. So we'll just say if it is 0, then just omit that value. Here I'll just say omit empty, and I'm gonna pass that to here as well. And now this basically says if the value is false, then just don't add it to the response, okay? Or let's just delete that and see what's gonna happen if we don't really add those fields. So we have our create to do function is up and running, right? Let's go ahead and test it out, where all I have to do is just update the port number because we have updated it. And for the body, let's say learn Python, and let's send the request. Now it says this has been created. Let's double check. If we just refresh our database, we should be able to see this Golang DB and then the to-dos collection. But here we can see the object ID is a value of 0 because that was the default value that it's going to give, right? Because that was the action. But here we can see the object ID is a value of 0 because that was the default value that it's going to give, right? This is the falsy value. And we're going to say if it is empty, then just omit that value and don't put it. And that's what we're going to do. Basically, we'll say omit empty. And now I hope you're able to see what this does. If it is empty, then just omit that. Let's go ahead and first delete this document. Now we don't have anything in our database, and let's create that again. And the only change is going to be this ID. It is not going to be 0, but it's going to be created by MongoDB, right? It's going to be a default value. Let's say learn Go, and let's say learn React. And if we now try to get to-dos, instead of getting null, we should have this array of objects, which we have 3 different to-dos, and all of them are not completed. It's because that's the default value, but we're gonna fix that next. So let's go ahead and update a to-do. First, shrink this function, get to-dos, create to-dos, and then add this endpoint where we have the update to-do function. So here in this function, again, we'd like to take the ID from the c.params, which is going to be the ID, and that's going to be type of string, and we need to convert it to be type of object ID. So I will say that primitive dot object ID from hex, and we're going to pass the string ID, which is going to give us, let's say, the error as well as the object ID. So I'll just keep this as object ID and then the error. Okay, so we need to do this conversion, otherwise we can't really compare it. So from this string, we just made it a object ID that is type of primitive, which is what MongoDB uses, right? So we'll say if error is not nil, which means there is an error. So here I'll just put it like that. And I think I'll just say invalid to do ID. So I'll just paste this line where we just sent 400 error status. And then here we just want to update a to do. So I'll just say collection dot update one, where we would like to first pass the context dot background. That was the default argument. Then we would like to add our filter, right? So which one that we would like to update, and then which field that we're going to update. So these are the two things that we need to create. And if you remember, to be able to create a filter, we would use bson.m. And if you just leave it empty, that's going to just say all document. Leave it a variable. I think I'll just so here in this function, again, we would like to take the ID from the c.prems, which is going to be the ID, and that's going to be type of string, and we need to convert it to be type of object ID. So I will say that primitive dot object ID from hex, and we're going to pass the string ID, which is going to give us, let's say, the error as well as the object ID. So I'll just keep this as object ID and then the error. Okay, so we need to do this conversion, otherwise we can't really compare it. So from this string, we just made it a object ID that is type of primitive, which is what MongoDB uses, right? So we'll say if error is not nil, which means there is an error. So here I'll just put it like that. And I think I'll just say invalid to do ID. So I'll just paste this line where we just sent 400 error status. And then here we just want to update a to do. So I'll just say collection dot update one, where we would like to first pass the context dot background. That was the default argument. Then we would like to add our filter, right? So which one that we would like to update, and then which field that we're going to update. So these are the two things that we need to create. And if you remember, to be able to create a filter, we would use bson.m. And if you just leave it empty, that's going to just say all documents, right? But we want to just get the one that has the ID of this object ID that we are getting from the prems. And the update field, we would like to just update the completed field to be true. So I'll say bson.m, and here we'll just say set to be able to update, and we'll say again bson.m, and the completed field is going to be equal to true. So this looks like kind of like Mongoose if you have ever used it. And if this looks a little bit complicated, it is just the syntax that you need to get used to it. And this is going to return us the, let's say,
just scale up and get used to it. Love the way you put that.
Like underscore, because we're not going to use that, and it's going to return us an error. And just assign it to that values, and we'll say if error is not nil, again just return that. So I'll just say if error is not nil, return it. But otherwise we're going to just return a success status with 200, and just like that. So I'm just gonna save that and just test it out. Also, let's close these, maybe save this one. So it was this, and let's rename this, because that's gonna be update a to do. If we got all to dos, we know that the first one is Python, which is not completed. I'll copy the ID of it, and I would like to update it. And here I need to update the port. So I'll say update this one to be completed. If I just sent that, here you can see it says success. And let's get all of our to-dos. This should be true now. There we go. If we just check it in our database, it should be working fine for the first one, which is completed. And the very last thing that we need to add is to be able to delete a to-do, right? That's going to be our very last endpoint. So let's close all of them and uncomment this function, shrink this one. Oops. So shrink this one actually, and uncomment this line. So here again, we're gonna get the ID just like we have done previously from the prems. So c.prems, oops, what is going on? Okay, I'll just do Control Z. I think it imported something. and I just did Control Z. Okay, so here c dot params, we would like to get the ID, and then again we would like to convert that object ID from hex. So we'll say object ID, and then the error field, it should be like this. So primitive dot object ID from hex, and then we're gonna pass the ID. So from the string we got the object ID of primitive type, and we'll say if error is not null, then just say return c dot status of 400, and then maybe JSON, and let's say fiber dot map. We could say error where the ID is invalid. So invalid to do ID. But if this is not really the case, then we would like to just delete one from our collection. So we'll say collection delete one, and again context dot background, just like this, and then we would like to pass our filter. So let's go ahead and create that. So I'll say filter is going to be equal to bson.m, and our ID is equal to this object ID. Oops, if I can type correctly, right? And again, this is going to return us two different values, which is going to be something that we don't use, and then the error itself. And let's say if there is an error, then we would like to just maybe return it. So if error is not null, then just return that. But else we'll just say success is going to be true. In this case, I'll just copy that line and paste it with 200 status code. Okay, let's go ahead and test that one as well. So that's going to be our port 5000. And then the ID that we'd like to add, let's say, since I am done with this one, I'll just go ahead and maybe delete it, right? Which is learn Python. I'm going to send that. It says success true. If we just try to refresh.
Skyfall Fibre is built to power the pros. Back at the lowest price of just £28 a month. Get game-changing speeds of up to 1.
And there we go. Now we can't really see that learn Python to do. And with that, I think we have completed this part as well, where we have just added all 4 CRUD operations, right? So we can get all of our to-dos, where we just say collection.find and pass an empty filter so that we could get all of them under this cursor, and we just loop through it and append it to the to-dos, this array or the slice that we have created. Then we just return it as a response. We can create one with the error handling, and we can update one with our filters, and then the update field that we'd like to update, and then we can delete one. So here we can see it is actually pretty easy to build an API with it if you know the basics. And here, this is something really important to keep in mind, that you would like to omit the empty values for IDs. Otherwise, it's going to be that object ID of value, that's 000, that we have seen just a couple of minutes ago. And here is how we can like connect to our database, and we're using this defer keyword to be able to disconnect once this surrounding function completes. So I think that's going to be it for this section. And next, we would like to build the front end and connect to this application from that React app. So instead of using Postman, we're going to use that React application. So I'll just go ahead and just add all my changes to the staging area and just put a commit. And we have some build errors. Let's see. So for some reason, this is not being ignored. Let's go ahead into the git ignore, and maybe I'll just say logs, and I'll just say .log. And with that, now that should be, if we just put it like that, that should be ignored. We just say, we just said ignore that, any file that ends with log. Okay, so these are the changes that we have done. This is the main file. You could take a look in the commit history. I'll just add my changes. So this is my commit message, second section completed, where we just store our data in MongoDB. I'll just commit the changes and I'll see you in the next section. Okay, so in this section, let's go ahead and create our React application. For this, I'll just open up my terminal and I'll just say make directory called client. There we go, it has been created, and let's cd into that. And now I would like to create a React application, which I'll say npm create feed at latest, and I'll just say that dot, so that it's gonna put that in the current directory, which is gonna be client. If we press enter, that is gonna ask us two different questions where we would like to go with React and TypeScript. So I'll just select React with TypeScript. Now it says run npm install because you got a bunch of different like in the package.json you have a bunch of different dependencies. You would like to install that so that you could get your not modules folder.
Love as well.
So that's gonna go ahead and grab all of them.
It's been a thing I've been waiting for since.
Now while it completes, we're gonna be using Chakra UI. So let's go ahead and say Chakra UI and take a look at the documentation. So this is a component library which is accessible for React, and we'd like to use it
so many things going on,
just to speed up the process.
Like Webpack.
And this is how we would use it. Let's first copy this command where we would like to paste it into the client directory, right? I'll just paste that, and that's going to give us the dependencies that we need. And let's go with the framework guide of Vite. So we have got this script, and it tells us to wrap our application with the Chakra provider. I'll just go ahead, copy it, and in my main.tsx, right, I'll just wrap it like this. And let's get the Chakra provider. So it doesn't give me for some reason, which is going to be this one. And by the way, while we're here, let's go ahead and delete the assets, delete the app.css, and in the app.tsx, let's just say p tag or maybe a button that says hello, and this button is going to be coming from Chakra. So there we can see, let's delete this app.css, Vite logo, and everything. Okay, with that, let's go ahead and also install a package called React-icons. We're going to be using them for the icons, and with that, I think we should be able to find with Chakra UI. Let's say npm run dev to be able to start our development server, which is going to be at this port. I'll just control click to it. It's going to open this localhost 5073. And there we go. Now we have this button that says hello. In your case, that might be a light mode. Here it is dark mode for me, but we're going to implement that so that we could switch from dark to light and light to dark. And also, this is the demo application that we're gonna build. So here we're gonna have this kind of navbar where we could go from light mode to dark mode. And here, let's just start with the navbar. So the very first thing that I'll be doing is to go into the app.tsx, and I'm just gonna wrap everything with a stack, which is coming from Chakra UI. And I'll say height is gonna be 100 VH, which is the entire screen. So we're gonna have a navbar, we're gonna create this component, and we're gonna wrap rest of our application in a container where we'll have a to-do form and then a to-do list. So let's take a look at the end result. We have a navbar, and the rest of our application is in a container, which just centers that here, right? So in the middle of the screen, we have a to-do form and then a to-do list, and each of them are going to be a to-do item, right? So this is a to-do item with check mark and delete button. And when you say stack, that's going to just put every child on vertical direction. So we have navbar at the top, and below that to-do form, and then just the to-do list. So let's start with the navbar, and for this we're going to be using these images. And for that, you need to visit the GitHub repo, and under the public folder, you're going to see a couple of different files. So just grab them and paste it into this folder. So I just copied all of them and I will just paste it into this file where we just have this explode.png, go.png, this Golang for the favicon, and we have the react.png.
Here's how Atera takes your team's IT efficiency from good to... Ooh. Okay, imagine being able to solve hours-long tickets like this in just 10 seconds. Ready? Go. Simply click the AI icon for instant ticket summaries, recommended solutions, and even advanced scripts as needed.
And we'd like to use that in the navbar. So first, let's comment this out and visit the navbar component, which we don't have. So let's create the components folder. Components, and we'd like to have the navbar.tsx. So here our focus is not really the UI design. So I'll just go ahead and copy and paste this code, which is pretty basic, and I'll just walk you through that. And you can find this code in this GitHub repo in the navbar.tsx. So we're never going to change this file later. So you could just copy that and paste it. So here we have a container with maximum width of 900 pixels. And we have a left side, right, which is going to be, let's see, it's going to be this left hand side with 3 icons with a plus and equal sign. And on the right hand side, we're going to have daily tasks with this kind of like toggle switch where we can go into light and dark mode. And here we just say background of this box is going to depending on the color mode. If you are in the light mode, this is going to be that color, and if you are in the dark mode, we're going to be using this color. And we're getting this hook from Chakra UI where we have the color mode as well as toggle color mode function. When we click to that, we're going to change the color mode as well as the icon. So let's just save that, import it, and delete this, and let's use it. So this is our application. There we can see it is here. We can switch that mode, but for some reason it is not being centered. And let's see why this is the case. First, I'll go into the dark mode, and it is because of this index.css. We have this additional styles that came with Beat. So if we delete everything in this file, and if we just refresh, there we can see it just works fine, just like in the demo application. So here you can see it is almost exactly the same, where we just make this icon a little bit larger. And the very next thing that we'd like to add is going to be this to-do form where we just have an input as well as an icon. So if you want to learn more about this dark and light mode, you could always take a look at the documentation where you would go into the color mode, and they have just example API. So let's say dark mode. And like if you visit use color mode, they're gonna just show you how you can make this toggle light and dark. And this is the exact same thing that I'm using because I just take that from the documentation. So there isn't anything complex in this file, and I'm not gonna explain that. It is just CSS styles. So you would just grab that and paste it into this file from the GitHub repo. And the next thing that we'd like to add is gonna be this to-do form. I'll just uncomment this and create this to-do form component. So here I'll just say RAFCE, and now we could really type this component from scratch. And again, there is not anything complex, so I don't really want to waste time on like the UI. I'll just go ahead and paste it. And if you want to get this code, I'll just put that at the very bottom of the file. I'll just say starter code, because we will change this code in the incoming minutes, and I want you to have this starter code while you're following along. Okay, so you would get this kind of code and paste it and just follow along with the tutorial. So here we have a state where we keep track of the to-do, and we are keeping track of that with this onChange, and this input is going to be focused by default when you refresh the page, and when you click to a button, it's going to make it scale, so it's going to shrink that. And if we are loading, we're going to show a spinner of size XML, and everything is coming from Chakra UI, and we have React icons if you want to take a look at that as well. And when you submit this form, we're going to just call this function which takes the event, and this is the type of it that is coming from TypeScript. which is a form event, and we'll just prevent the default so that it doesn't refresh the page, and it's going to say to do added. Later, we're going to add this functionality so that we could actually interact with our MongoDB database. Let's save that, and we have an error, or it's just a warning. It says you are not using that, but we'll use that later. Okay, let's save and just see that in action. Here we go. We have this input and the button. If you refresh the page, this is gonna focus itself by default because we have this line of code. And when we just add anything into here, it's gonna say to do added with this alert. So that's gonna be to do form component. And if you really want to see the like the UI design, just pause the video, take a look at it from the starter code. Basically, we have a form and we have a flex. On the left hand side, we have the input, and on the right, we have the button. If it is pending, let's just make this to be true. We're gonna have this loading state into it, but else if it is false, we're gonna see this plus icon. And next, we would like to build the to-do list component so that we could just see this data. I'll go ahead and create that one, to-do list.tsx, and in to-do list, we're gonna have to-do item.tsx. So here I'll just again get the starter code, paste it twice so that you could use it as well. And again, this is pretty simple file. I'll just paste that and I'll paste it again, comment this out, just like here, and I'll just say starter code. So you would copy and paste that part. And basically we have fake data, right? 3 different to-dos: buy groceries, walk the dog, do laundry, and cook dinner. 2 of them are completed and 2 of them are not. So I'll just shrink this to-dos, and we have a loading state, and we are importing the to-do item for each to-do, right? So I'll just go ahead and add this to-do item as well. And this is going to be the very last thing that we will copy and paste. So about 40 lines of code, and I will paste it again. Starter code, for those of you guys that want to follow along, right? Okay, so these are just styles. That's why I don't really want to waste too much time on it. And okay, if we save this file and this one, this is taking a to-do as a prop, and we're just giving that type with TypeScript. And for each to-do, we'll just check if it is completed, then it's going to take this green 200 color, but else that's going to be yellow 100. And we'll just check. So we're going to give this line through if it is completed, right? So just like that. If it is not, it's going to have this normal text. And if it is completed, it's going to have this done badge. And if it is not, it's going to show this in progress, right? So this is not completed and this is completed. Then on the very right hand side, we have check mark and then the delete or the trash icon. So that's going to be it. Let's save and see that in action in our application. First, we need to go into this component and import it just like this.
With Google Workspace, Calendar lets you share your latest availability. So
it's going to refresh, and there we go. So here we have a loading spinner. Is because we have this loading state is true, and we just check if it is loading, just show a spinner of size X large. And let's say by default that's going to be false, and there we go. So this is the today's task, where we have just a couple of them, and all of them are fake data. And also let's go ahead and update this title to have this kind of a gradient. And for that, we could check the documentation. Let's say gradient, and here we can see they're using it on the text. And I'll just give you this BG gradient linear to left, right? You just put the right value and then the left one. So if we just put something like maybe blue, it's gonna go, okay, so it goes to left. So that's gonna be the right value, and this is gonna be the left value, which is this pink color. Starting from right with blue, it's gonna go to the left with this pink color. And let me just give you the styles to be able to get this kind of linear gradient. So here, let's just go ahead into the to-do list where we have this text. I'll just give these styles. starting from this color to this one and bg clip of text so that we can get this end result. Now everything works fine. It is time to actually add this functionality and grab these data from the database. And for that, we'll be using TenStack, also known as React Query. So if you visit...
This is where we're going to start for today. Well, turn this off. Well, that was oh, it's gone crazy. It's stuck down. Yeah. Well, that was the first foray into learning Go. I really enjoyed it so far. You might have noticed me like nodding off a little bit at the beginning and stuff. Like it's just a long day, busy and stuff. Got to try and keep myself focused. All the React stuff is like, you know, it's nice to see, but I already know like all that and stuff. But the Go, just those little introductory videos to Go are really useful. Melky, I'll definitely go back to your video and pick out some of those resources because I'll definitely use those going forward. Once I've gone through some of these videos, I'll switch track and get to putting some muscle memory to work. Start building up that muscle memory and yeah, start writing Go. So yeah, this is the first one of these types of streams. So we're back next Wednesday, just carrying on where we left off, like the basics. And yeah, we'll see you then. Cheers. Have a good night.